So welcome to Progressive Delivery Patterns in the Wild. This is why I give this talk. So the future is already here, it's just not very evenly distributed. I don't know how many of you feel that way, but what I'm going to describe is actually not entirely new. A bunch of companies have been doing it for years. But the issue is that it's still not widely adopted, right? It's not something everybody's doing because it seems like it's rocket science, or it seems like something you have to be a unicorn with a giant tools team to do. Not true anymore, and that's why I give the talk, right? How can we actually democratize this so more people can take advantage of these methods? So this is how we'll roll. First, we'll just kind of make sure we're on the same page. What is progressive delivery? Then the meat of the talk, patterns in the wild, and then awesome checklists at the end. And depending on how much time we use here, I may just kind of hand you the checklist, or we'll go through them item by item. But everything you'll see will be in the resources section, which I'll put up a QR code at the end, where you can just snap that. Also, it'll automatically go out on Twitter in the last 1 minute of my talk, the same URL. So that's a page with 12 different resources related to the talk if you want to go deeper, including all the slides and all the checklists, right? And then it's up to you. The discussion part's up to you guys. I'll give away my microphone, and we'll see how that rolls, right? So what is progressive delivery, and what are the potential benefits? And there's one definition that Carlos Sanchez, who's now at Adobe, he wrote, which is great. I'm literally going to build it out a line at a time because it's a really well-parsed way to kind of, what is this, right? Well, progressive delivery is the next step after continuous delivery, where new versions are deployed to a subset of users. It's really important, a subset of users, not a big bang. And they're evaluated in terms of correctness and performance. So not just are they buggy or not, but do they do what they're supposed to do, and are they performant? Are they fast enough, right? Before rolling them out to everybody. So what if I could find out first how it is before I give it to everybody, right? And then finally, they're rolled back if they don't match some key metrics. So if you don't accomplish your goals, then you roll it back. You don't roll it out to everybody, right? So it's not an unstoppable force. It's actually a clever way to kind of test the waters. So where did it come from, though? What's the origin story behind progressive delivery, right? Turns out that Sam Guckenheimer, based up here in Seattle, worked for Microsoft, a product guy for Azure DevOps. He was having a conversation with James Governor, also known as Monk Chips, from RedMonk, and he was explaining how they were rolling out stuff through a variety of techniques. And he put it this way: when we're rolling out services, what we do is progressive experimentation, because what really matters is the blast radius, how many people will be affected when we roll it out, and what can we learn from them. So he used the term experimentation, which is actually more specific, which is he really wanted to learn for sure. It's also progressive, right? And James Governor was like, he's been seeing Istio this and Istio that and canary releases and all these different blue-green, like, oh, wait, maybe he could come up with a term that would sort of be a basket for all that stuff, and that's progressive delivery. So he wrote a blog post in August of 2018, and it was about a new basket of skills and technologies concerned with modern software development, testing, and deployment, right? So now you know kind of where the term came from. Let's talk about the potential benefits. Why do people, there's a reason people do this, not just because it's cool, right? So the first one is to avoid downtime. Does anybody remember maintenance intervals? Yes. Right? Who likes to go to a website and see that we're down for a maintenance interval, right? Or a mobile app? Not really so much. And worse yet, a mobile app that just throws errors because, well, it's a maintenance interval, of course, right? We want to avoid downtime. So how do we actually avoid having this downtime between releases? If we're going to release often, we can't have a lot of downtime based on releasing. And how can we limit the blast radius? So if I'm going to roll something out, how can I make it limit the blast radius both in time and scope? Like if something goes wrong, how can I make it not last very long? And how can I make it not affect very many people? Because if I fall on my face, but it only affects a handful of people and I'm fixed very quickly, it's not a very big deal. But if I bring my whole solution down for a day, life's not good, right? Limiting work in progress and achieving flow. So these are fundamental concepts about sort of Agile and DevOps and how do we turn the crank faster. One of the ways you do this is by having smaller batches of work. Right? And so what's a release technique that facilitates lots of small pieces instead of a big bang, right? And then finally, how do I make sure I learn during the process? This isn't how do I put everybody on call during the process. This isn't how do we all stop what we're doing and pay attention to all the screens during the process. Who here has done a release night after hours? Right. Kind of exciting. Not really fun to call home and say you're not coming home for dinner. Right? And it's extra exciting if something goes wrong and you're there till the next morning, right? But what if I could learn during the process without it being a fire drill, without being at 100 people staring at screens, right? So I've created this matrix. Now, there's the 4 things: avoid downtime, et cetera, down the left side. Those are the benefits. The approaches, so how you roll, how you do progressive delivery matters. Yes, it's a basket of related technologies, but what you choose and how you use it will affect how well you can check these boxes, right? So first is blue-green deployment. This does an amazing job of avoiding downtime. Why is that? Well, you stand up a copy of production, and you have as much time as you want to make it just the way you want it. You can install everything, you can test things up, smoke test it, just be ready, and then only when you're sure that it's ready to go, you route traffic, typically with a load balancer, from blue to green, and now you're sort of crossing your fingers because hopefully everything's going to work, but you now get a chance to, as people flow into the green, to see if it's going okay. And if you missed something, what do? You just route back to blue because it's still there. Right? So you've got really 2 versions, and really this is a cloud thing. There aren't a lot of people that would have 2 data centers. Some do, but so great at avoiding downtime because you can take as long as you want to do the preparation, and then you can cut people over live. Limiting the blast radius, I give it kind of half credit, and the reason why is temporally, time-wise, it totally checks the box. Because if you can switch from one back to the other in minutes, it's pretty good, right? It doesn't necessarily mean you wouldn't have shown all your users something horrible for a few minutes or been down, but it does mean that you can get back quickly. And then the achieving flow part, not so much, because it's a monolithic. You're doing a big release, right? Big bang. Everything at once, good or bad, switch it back, right? And then learning during the process. There's nothing inherent to blue-green that helps you learn the things you just changed in this release. How did they affect what happened? Because you've got this big beast, right? You've got this big release that you've done. So then canary, right? Canary release, also good at avoiding downtime. This is basically, let's say I've got 100 instances of my app, and I spin up 2 new containers or 2 new servers or whatever, and I start with a new release, right? And I route 1 or 2% of my users through those other servers, and I can then watch them very closely, right? So this is great for avoiding downtime, because again, I can kind of set up those canaries on my own time. The rest of production's still up, right? And limiting the blast radius, it does this really well because I can stop routing people to those canaries and sort of drain out that traffic, and I've limited the time that the blast radius is packing. And if I'm only going out to 1 or 2% at the beginning, I'm limiting the scope of the blast radius. So it checks that box really well. Achieving flow, actually not so much, because again, this is kind of a release as a big bang, right? You're big banging on one small subset of your servers, but it's everything in the release. It's all 5, 10, 15, 20, 30 feature changes that are in that release, right, in that bundle, right? Now, if you're super microservice-y and truly these containers are only doing one thing, one function in the whole world, okay, but most of us have payloads in a release, right? So learn during the process. It gets a quarter credit here, and that's because if I'm going out to just 2 servers, I can pay a lot of attention to those 2 servers, and I'm probably going to see obvious things like CPU or network traffic or any of that kind of stuff that's going to be a big red flag. It's only getting a quarter credit because if I've got 5, 10, or 15, or 20 things in that payload, I still don't know which one's causing those problems, really, right? I still have to dig in there and figure that out, so they don't shout out and say, it's me, right? So that's canary. Feature flag rollout. So with feature flag rollout, you actually deploy code turned off, and you turn it on whenever you want for as many users or as few as you want, and you can use attributes for who should get this feature, or just random or whatever, and ramp it. So it lets you avoid downtime because you can actually push a feature out and have it off, right? Limit the blast radius. It checks the box really well here because I can start with 1% and 2% and 3%, and if I see problems, I can roll it back. And also, I can actually, I can focus, so time and scope. I'm a small number of users, and I can change it instantly. It does not take a deployment or a hotfix to undo a feature flag rollout. You just literally send a different signal to the system. And then limit work in progress on achieve flow. Really good for that because every feature has its own flag. Each one is independent. Now you may have dependencies you want to enforce, but you're not stuck on a release train with 15 other pieces of payload. You're each one on their own with their own switch. Okay? Learn during the process, actually not so much, because there's nothing inherent to using feature flags that let you know which feature is causing which problem. If you take 10 features live in a release and you're ramping them up and things start to go wrong, you still don't know which one's causing it, really, right? So that's where the next one comes in, which is a feature delivery platform. So in this case, it's really the same thing as feature flag rollout, except you inherently build in the telemetry to understand how the system's behaving and how the user's behaving at a user level. So if I'm going out to 5% of my users, I want to know how is the system behaving differently for those 5% than everybody else, or how are they behaving differently, right? And that's the model in the wild that I'm going to focus on, because that's, to me, that's the deepest shade of progressive delivery. And I have a blog post that goes way into more detail about how these things work and why that you can read. That'll be in the materials at the end, right? So let's look then at what I would consider the three main characteristics of a feature delivery platform. First one is you need to manage, and that's really about managing gradual exposure. So I'm going to manage gradual exposure. We'll also learn about how we're going to limit the blast radius. Now we're going to learn. But I want to manage gradual exposure. And often this is called decoupling deployment from release. How do I actually make pushing bits around just infra and releasing to users something I control separately, right? And then monitor. So I want to limit the blast radius. How do I do that? I need to know how the users in the system are behaving early on in the rollout, not after a preponderance of evidence shows up, right? I want to know soon. And then finally, to experiment. Now, a lot of people see experiment, they think, well, I'm not a growth hacker. I'm not in marketing. I don't do A/B testing. I don't blue button, red button. That's not what I do, right? But engineers, DevOps people, all of us, we're trying to have an impact, right? And if you look at the bottom there, it says data informs a hippo. And I'll get to that in just a second. But we want to confirm that the thing we're trying to accomplish actually happens before we check done, right? Done means it actually did the thing we wanted it to, not just that we shipped it and there's no obvious bugs. Okay? Who knows, does anybody know who the hippo is? Anyone heard of the hippo before? You have?
Highest paid person in the office.
He said highest paid person in the office. I would say highest paid person's opinion, but pretty much the same thing. So have you ever been in a meeting before where there was somebody who had sort of a senior title, who was involved in a decision-making process, who wasn't necessarily the most technical person in the room? There's supposed to be giggles and right? So guess what? It's not comfortable to be that person or to be the technical people who are about to be told what they ought to do because of a gut decision, right? It's actually way more fun if you can do some experimenting and say, well, we did this and we did that. What do you think we should do? And the hippo says, well, we should do that, of course, right? The thing is, they're great for breaking ties and for setting a mission, but they shouldn't be asked to make technical decisions about stuff that you know more than they do. So experimentation lets you actually have hard data to reverse the flow so that you can inform the hippo and they can basically help you all move forward, right? It's more sustainable. So here's the meat of the talk. Let's venture into the wild, right? So the first one I'm going to cover is Facebook Gatekeeper. And Facebook Gatekeeper, Facebook obviously a lot of scale, right? So they had a lot of scale in users and a lot of scale in actually developers very early on. And they wrote this blog, Kent Beck wrote this blog post in 2015, Four-Headed Monster Complexity, right? And the four heads are this. States. In a complex multi-part system, it's very hard to track or predict states, right? Interdependencies. It's also very hard to figure out how everything affects everything else when it's a complex system, right? And uncertainty. The world's an uncertain place and you can't really control uncertainty. And then they stumbled on this, irreversibility. So what if you could have an undo button for almost anything you did that worked pretty fast? Wouldn't that make life a little better, right? And so like that's the one part of complexity we're going to focus on in this effort of Gatekeeper. And so what they did was and this is again, this is a prototype for something you'll see repeated in a lot of other places. So earlier there was a conversation, should we call it dog fooding or should we call it drinking your own champagne? Anyway, running your own code internally. Facebook's actually a very heavy user of Facebook. But they also have a communication channel that doesn't rely on Facebook. And so instead of dealing with interdependencies by having a change control board, a change review board, instead they have the teams just kind of go for it, and during the first hour of a rollout of a change, they look for impact inside the company. Hey, you broke my thing, right? And if somebody finds that, they stop the rollout. Okay, so they have a 1 hour window where they're dog fooding or sipping champagne, right? And then they do a staged rollout. So this is, again, going out. Now, if you're Facebook and you go to 1% of your users, you've got some pretty good data, right? We're talking millions of people, right? And so Microsoft explained this same pattern they were using, and they said, well, you know, it depends on the feature, but some things might take 3 weeks to go from the very first cohort to everybody gets it. Right? Because some people are in the don't move my cheese category, like don't ship me stuff until it's totally baked, right? Well, at Facebook, they go through from 0% to 1% to 5% or whatever in 4 hours. Okay? I had an SRE tell me this. I don't know if that's always how it is, but literally it's about 4 hours because by then you've disposed of billions of people, you know it's okay. Right? Now, you and I don't have that scale, but we can still use the same model, which is I go to some people, I watch what happens, I go to some more people, I watch what happens, et cetera, right? Staged rollout. And then dynamic configuration. It's not about a patch. It's not about bringing up or taking down servers. What if I can control how the system behaves pretty much with a dial anytime I want, and I can dial things up and down in very fine detail to find those nonlinear impacts on each other, right? And then finally, correlation. So how do I find unexpected consequences easily? How do I make it easier that I'm going to find the stuff I wasn't looking for because I can track the changes and sort of watch what's affecting what, right? So again, that whole, that's more in my materials. So let's move to LinkedIn. So they had a system called Excellent, also known as LinkedIn Experimentation, or LAX. And in the early days, it was fairly basic, okay? And they built a targeting engine that could split traffic between existing code, status quo and new code, and they could assign people to that. But the impact analysis was by hand, and by their own admission, it would take about 2 weeks of begged favors to figure out, well, how'd it go? Right? Now, and so they basically never did it, or very rarely because it was too much work, right? It was a fire drill, right? So the bottom line is at the beginning, they pretty much had feature flags without the automated feedback loop. But if you fast forward to today, they do a controlled release with standardized KPIs being automatically calculated every 5 minutes. Like they launch a new release like that every 5 minutes. 100 releases a day they can push out. All of them know how they're doing and report back. I'm doing fine. Well, I'm hurting people, right? So pretty powerful. They also have a system called Metrics You Follow, where any stakeholder can subscribe to things they care about. Maybe it's subscriptions to a newsletter. Maybe it's signups for a premium service, whatever. And any rollout that's influencing those stats for the better or the worse causes a proactive notification to that stakeholder who cares, right? So they get notified, I don't know what's HipChat or Slat or what they use or email, but they get notified of those things changing. So they're an extremely mature case, right? But I want to, and before we move on a little bit, I want to talk about guardrail metrics. Has anyone heard this term before, guardrail metric? So a guardrail, what's a guardrail for in the real world, right? You're driving along, it's along the side of the road, and if you get a little distracted or you get a little off course, you bang into the guardrail. And you might dent your car, but you're not going to fall off the cliff, right? Good thing, right? So in the software world, what this is let's say a team is trying to get users to create more tasks. I want the users to create more tasks. And in this case, they're crushing it. They're getting 11% more tasks out of the users. So they think they're heroes and they're high-fiving each other. The problem is if you got this data by doing database queries, oh yeah, we're getting way more tasks. You might miss this little tidbit, which is that people that went through that code instead of the status quo were getting 25% more latency. It was much, much slower, okay? If 50 milliseconds will drive people away from your app or your website, a 25% hit on your latency is not good. And so you might be off celebrating at the beach that you're heroes. Meanwhile, there's churn happening and you understand why you're losing users, right? So a guardrail metric is something that's automatically calculated all the time without the dev team having to worry about it. And it's not a pair programming best practice. It's not a checklist item. If it's not automatically being calculated without the developers having to think about it, it's not a guardrail metric. Okay, so the whole idea is how can I just have that stuff be known and find those unintended consequences of things I care about as an organization? That's a guardrail metric. So I want to wrap up with LinkedIn on terms of the lessons learned. So this is Yazoo. She started out as an individual contributor and played a part in kind of scaling up all this stuff, and she's head of data science there, and she's just about to publish a book that's already written, but it's just not live yet, on experimentation, along with Ronnie Kohavi, and I apologize, someone from Google too, I always forget the third name, but they're putting out a book on experimentation. But these are the things that she shared at a conference that Split did in 2018, and it was, you have to build for scale. So if you're gonna build a platform for this for yourself, or you're gonna implement one of some sort, they originally would coordinate over email for which range of user IDs could be used for an experiment. I want 37 through 42. No, I want these, I want those. Right, and you can't get to 100 launches a day if you're debating over email for who gets what cohort, right? They also had this problem, making it trustworthy. And this is the story they told, which was you'd go into the system on one day and it'd be like, congratulations, you're up 50% on your goal. Oh my God, you're a hero, right? And you go home and you're like, tell your family, oh, we're doing an amazing thing, it's great. The next morning, first thing you do is you grab your boss and you say, I gotta have 5 minutes of your time. You're not gonna believe this. I gotta show you this. And so you bring up the screen and there it says, you're down 50%. You're making it 50% worse, right? I don't know about you, but if you had a system like that, would you use it? No, you'd be afraid of it, right? You wouldn't, hey, everybody, we should use this. So they had to fix that. They had to make it reliable and trustworthy. Otherwise it wouldn't, A, people wouldn't use it, B, other teams wouldn't believe them, right? And then finally, designing for diverse teams. And this is really related to the same issue, which is if there's a wizard who owns and understands this thing, it's very common we build something and there's one or two, maybe three if you're really lucky, people that know how that thing works, right, or maintain it, right, and it's their little baby, right? The problem with that is A, they're a bottleneck, and B, it's kind of their thing, and other teams might not believe that data, right? So they wanted to design for diverse teams, not just data scientists, so that everybody could use this. And that is what they did, right? So that is how they ended up. Now, the last one I want to cover is Booking.com. And the reason why I want to do this one last is this one is actually a really, A, well documented, and B, it's sort of a perfect example of the whole system. You know, LinkedIn was probably more focused on manage and experiment, a little less on monitor, but they have another system that kind of does the monitor, right? But think about it. I want to manage, monitor, and experiment. And Booking, this is exactly what they've done, and they explain it really well in this blog post by Lucas Vermeer, right? So moving fast, breaking things, and fixing them as quickly as possible. And so let's look at how they do manage, right? So they call it asynchronous feature release, which is just another way to say I'm decoupling deployment from release, right? And they wrap everything they do in a simple function call that says, should I expose this to the user? And it's not necessarily a UI thing. It could be an algorithm in the back. For this particular user, should I run this new code or not? If yes, I do it. If not, I go around it. I don't do it, right? And so let's talk a little bit more about, so what's a feature flag? It's kind of like having an ability to turn something up or down remotely without having to do a new deployment or change anything. And you'll notice that the first line there is 0%. Why would I deploy code to production and expose it to 0% of my users? Anybody know? There's actually two main reasons. Yeah? The change might be buggy. Okay, so that's the second reason. I'll cover the first one, actually. Has anyone heard of trunk-based development? Did anybody hear Jez say this morning, how many of you are actually really doing CI? Are you committing to master once a day? Right? Well, if you're doing trunk-based development, you're supposed to commit to master at least once a day, and you're probably supposed to deploy from master. So people that do that actually use feature flags to turn stuff off that's not finished yet. So it actually goes all the way out to prod, but it's not executing because it's turned off, right? The other reason you do this is that it gives you one last chance for the developers and the testers to validate a feature in production to find those unanticipated bugs, right? And how many people fear testing in production if 0% of the users are being exposed to the code? It's a little less scary than saying, oh, we're just going to test in production. You're like, you can't do that, right? And it doesn't mean you don't test, but it means that you also test one last time in production. Then you can ramp it up from there, right? So, so this is their experience with sort of manage, what they call asynchronous feature release. So deploying has no impact on user experience. This may sound self-evident if once you realize that deploying is separate from releasing, but deploying doesn't hurt anybody because it's the releasing, the turning it on, that could hurt people, right? And they find they deploy more frequently with less risk to the business than to the users, right? So the net result is that they're much more agility. Teams are more willing to try things and they do things more often, and it takes them less time because they're not as freaked out about breaking everything. Because if they do break something, it's going to get handled. And we'll talk about that in a second, actually. So monitor. How do they do monitor? So first I'm going to do a little math with you. So I call this monitoring the needle in the haystack. So if you roll out a change to 5% of your users, I know it's late in the day, but I'm sure you guys can do this math. 5% of users are getting this code. The rest are not, right? But 20% of those users are getting an error. So 1 in 5 of those users is getting an error. What percentage, first of all, that's a huge problem. If you knew 20% of people are having an error, would you have a meeting about whether you should roll it out more? No, you wouldn't do that, right? But what percentage of the users are getting this error right now? 1%. Very good. You guys are much faster than some of the other crowds I talked to, right? So yeah, it's 1%, right? So what does that look like graphically? Here's sort of a global error level graph in a NOC somewhere, and that's kind of ambient noise level of errors that are happening, and 1% is down in there, right? It's down in the ambient noise. You're not even going to see it. And some people say, well, that's okay, because when we go from 5% to 10% and 20%, that line's going to be above the horizon. We'll notice. But again, we all agreed that if I knew that 1 in 5 people were being hurt, I'm not going to roll it out more, right? It turns out that if you actually watch, if you monitor with the same mechanism that's doing the doling out of who gets what, if the thing that tells which 5% they should see this code is also watching to see how it's going, it's trivial for that system to know how it's going. Right? As opposed to trying to parse this out of your global metrics or get it out of log files or something, right? So this is their experience with monitor. They call it safety net. Each new feature is wrapped in an experiment. In fact, even infrastructure changes are wrapped in an experiment. I have another talk where I go into detail on this page you worked on for 6 months, and it's, if you get a chance to watch it in your copious spare time, go for it. So it allows monitoring and stopping individual changes, and importantly, the developer or the team that rolls out the change is the one in control of whether it goes up or down. You build it, you own it. Anybody work in a shop where at least you're moving towards, you build it, you own it? Developers carrying pagers, et cetera, right? So who's going to know whether the feature is behaving the way it was designed? The people that wrote it, or the engineer on call from a different group, or some generic ops person, right? Again, kind of intuitively obvious, right? But now, regardless of who deployed the code, the team that actually wrote the feature is in control of it going up and down, right? And they're responsible for keeping an eye on it. But that's not good enough for them because they're highly evolved. So they built something called a circuit breaker, which is an automatic way to stop stuff when it's really, really inherently evil, right? And so for the first 3 minutes of a feature release, if they see severe degradation, they automatically abort that feature. No one gets to decide, it just happens, okay? And this is an acceptable divergence from the sort of local team autonomy thing, because if everybody's being hurt, you don't really have to debate. It's kind of like the 20%. If you know 20% of the users are being hurt, you don't have to decide, well, what do you think? Should we roll out more of it? No, you'd stop it, right? And so what happens is they get an alert that says, hey, yo, we turned your thing off. Here's why. In this case, there were a lot of errors and even more warnings, so it violated the thresholds and they automatically stopped it. Try again, right? The crazy thing is that they can do this. So who's ever heard of mean time to detect or mean time to resolve, right? Okay, good numbers there could vary depending on where you work. In this case, both of those happen inside of a single second. So you go to a web page and it's scrambled. There's something totally broken about the web page. And you're like, huh, maybe I have a network problem. And you hit refresh and it's fixed, right? Now, somebody's logged a problem and they're now trying to figure out why it hosed the page. But the users literally were out, right? Crazy stuff. And by the way, you don't have to get to 1 second. Who's been in a war room that lasted more than an hour? More than 4 hours? Anybody been like all day? Right, okay, you all have. How would 5 minutes be? Right, 5 minutes would be good for quality of life, I would think, right? Did you say 3 days? I'm not sure if he said 3 days, but he might have. So the last thing, experiment, and I want to go over my time, so we gotta roll through here. So they see experimentation as a way to validate ideas. Again, it's not some growth hackers thing or some marketing campaign thing. Experimentation is a way to validate, we think if we do this, this other thing will happen. Let's make sure it does that before we say we did that, right? Before we're, So how do they measure in a controlled way the impact their changes have on user behavior? And they're focusing more on user behavior, but they do watch system behavior too, right? Every change has a clear objective that they have to state up front. So let's cover the very complex science of hypothesis first for a second. Like, because we've seen this, we believe if we change this, this will happen. So literally that's kind of the most straightforward way to put it, and they have to document that before they actually push their change. It's not like a massive research project. They just have to say, we think if we move this around or put fewer answers or whatever, it's going to be better for the users, here's why. And it allows them to validate the desired outcome is achieved. And again, if you look at feature flags, you're splitting a population in half. It doesn't have to be all your users. It could be just your free users or just your 18 to 35-year-old users. But you're splitting them in half and you're sending half of them through status quo and half of them through the other thing. And then you're watching to see how they differ, right? And this is a way you can prove what's happening, right? So the big takeaway they have is that the quicker we manage to validate new ideas, the less time is wasted on things that don't work. Show of hands, anyone work for 6 months on something that ended up on the shelf? I will raise 2. Okay, it's not much fun, right? I mean, it may be fun if you got some good dinners along the way and went out for a team building or something, but it sucks to put something on the shelf after 6 months, right? So the more time is left to work on things that make a difference. And really fundamentally, if you're in technology, it's probably nice to get paid well, but you would probably like to make an impact. And if you can make your company or the world a little better, it's a lot more fun, right? So for the checklists, I've only got a minute and a half left, so I'm just going to show you what they are. They'll all be behind the URL that I'm just about to tweet out automatically, and they'll be at the QR code you see here. But basically what I've done here is I've broken this into foundational capabilities. First one is decoupling deployment from release, right? I want to be able to make changes without a new deployment or a rollback, and I want to be able to, target various ways. Not just routing network traffic, but like getting it to users and populations and such, right? Second one is I need to automate a way to see who have I exposed this to. I don't want to run queries ad hoc. I want it to be really obviously easy to know who's got it, who hasn't. And likewise, I want to do that for how it's going. I want to automate how it's going. I want to be able to calculate the comparison of system health between the people that have it and don't, comparison of their behavior between the people that have it and the people that don't. And I want to make it really easy to have guardrail metrics be automatically calculated so it's not, so that the developers are saved from the local optimization trap without any extra cycles. And then there's two, these I'm not even going to go all over. Basically, for monitor, you need to assemble those pieces and do these clever things, and you can read about that after we're done, right? And for engineering for impact, for experiment, again, you want to focus on what works, and so you assemble those foundational capabilities in this model, right? And that will let you get it done. So I've shared this because I believe that, like, whatever you are, you might as well be a good one. It's a lot more fun to actually do what you're doing well and to know that it's working. And here, by the way, is that URL. If you just hit this with URL reader, for those you Apple users, swipe down from the top left. It should be one of your widgets. And this is also on Twitter. So if you look, a minute ago, this got tweeted out on Twitter. You can just click on it there. So I hope that you know a little bit more about progressive delivery and how it's actually done in the wild now than you did before we started. And now, actually, we take away my mic, and you guys get to have the conversation. So thank you for your time.
Yeah, so I guess we're one of these a little bit older school organizations that doesn't do everything in a public cloud, and we manage a very, very large global infrastructure, and everything from the applications we deploy to the containers they run in, to the virtual machines that they're in, to the hypervisors, to the firmware that it runs on, and trying to apply a lot of these types of practices, which we've been trying to do for a while. We find it works really well when you have a lot of control, meaning that everything that you are deploying is tools and software that you're building. But for things like lower level patches, operating system updates, firmware from vendors that you don't have control over, it's very difficult to implement these types of practices with, like feature flags and things like that. So that's a big challenge.
Okay, great. Dave, do you have thoughts?
I thought I wasn't supposed to weigh in.
No. Please, yeah, please.
My mic's on? Yeah, cool. So, so totally hear you on the sort of operating system, like the stuff that you're not in control of, and that kind of sucks. I really haven't heard of people using this approach to deal with things like OS patches, but I bet you could actually, there's probably some ways to do that, but typically this is about things you are in control of. But the fact, it doesn't have to be cloud, by the way. So you could be in a data center, and as long as you have a way of orchestrating the state of these feature flags and monitoring what's happening, you don't need to have, it doesn't have to be a cloud solution. By the way, doing blue-green would be really hard with your own data center, right? But actually doing a feature flag rollout is actually pretty straightforward. I apologize, I wasn't listening to everything he said because I thought I was supposed to be basically switching gears.
No, we want you to include.
All right, I'm here.
Everyone should be included, and
Okay.
we all have some level of expertise or questions about this.
So by the way, I don't know if have you guys tried sort of the kind of canary approach? Was that we put the patch on a subset of our servers and then we run it in parallel with the other ones and see what, right? Right. So that's progressive delivery in a way, right?
Sure.
So that's you're instead of, okay, well on Thursday we're going to drop the system for 30 minutes and bring it all back up on the new stuff, right? That's the old way people would do stuff, and it wasn't 30 minutes, right? And the new way would be, well, I'm going to route some of the traffic to a smaller subset that I've patched.
Right.
And if it's ugly, I'm going to stop doing that.
Yep. We use those practices, yeah.
Yeah.
Okay, what other challenges are people facing? Yeah, please.
Our team maybe overused the approach with flags. Basically, every code change introduced was going through that. And the problem is that nice polymorphic architectures now are full of terrible if-elses all around the code. And depending how function is written, sometimes it's a small if-else that looks nice, and sometimes it's like the same if-else replicated in multiple places. So I think there is a certain amount of negative that can happen if people overuse or abuse this approach. Another thing I have is, and maybe, I don't know, maybe immutable infrastructure is already like too old concept, but infrastructure, according to some, supposed to be immutable. But now you introduce a state that is not in your repository. it's sometimes in split, like third-party vendor,
Right.
that now your production code depends on. So it's, I think there's a little bit of contradiction between two different schools of delivery.
Right.
Just a variety of response. So I'll actually respond to. Oh, sorry, I'm not supposed to do that. Yeah. To both of those. So, I mean, on the one. So on the thing about the overusing the feature toggles and feature flags and those kind of things like that. I think it's less a thing of overusing, but it's more of like cleaning up. It's like just like with anything, you have to kind of like have good discipline and say like we're going to put these things in and then we're going to remove them, which might mean you need to have like ways of implementing that so that it's easier to do than going through all of your code and removing if else's. So that's one thing I'd say on that. And then the immutable infrastructure thing, I don't think it's necessarily contradictory. I think with immutable infrastructure, the way I think about it, it's it can be done with pieces, right? So it's like with the question of like servers, if the way you do a patch to a server is you create a new server and roll it out, that's an immutable server. You don't have to do that to all of your servers, right? If you have a pool of servers, you can do like rebuild one server, add it to the pool, remove other ones. So I think that you can use those concepts together. That's my thought.
Actually, to his point,
You're fine.
So to his point, though, about it seems like there's this other place, this other repository where the facts are about whether something should be on or off, right? So that is a really good reason why you don't want to have 3, 4, or 5, or 6 different ways you're doing this in your shop. Or like I worked in a place where we had a nice little admin screen and it had some physical toggles and some things that just told you the state, but the code behind those differed by which team built it, right? And so that is not there's no one version of truth there. Now, if you're going to trust a system, a commercial system like Split or one that you build, you need to make sure that everything's on there and predictably how are things named, where are things stored, what is the convention for naming in the code. Like there's sort of basic hygiene things you can do. And then as he was mentioning, like the notion of a feature flag should never be long-lived unless it's a toggle that's meant to like shed load in a bad situation. If it's a transition from one version to another, it should come out after it's at 100%, right? And the stuff that's no longer being used should be ripped.
I've seen a similar thing with the overuse of the flags. And my husband works on a public app that we use at home. And he came home one day and we were using the app. And I made him do it. And because I usually use it and then I yell at him. And he saw something. Someone had 2 features on, and there were the design part when laying out had the wrong corners and 2 carousels. And he knew, because he would know this, he knew that like two people had put up experiments and they had not consulted the design, and he put a message in the Slack channel to fix that.
So they collided.
Yes, they collided on the design style, and he had 2 carousels on top of each other with the wrong corners, which I don't see those corners. That's why I have a husband who sees the corners. I didn't see it, but he saw it on his version of the app. And so you can get too much in there, and if you're not thinking about what the user experience was, he happened to catch that experience on his phone, and he was like, "This is not right.
Right.
This is not right." It was just too much.
Sure. Okay. Cool. And I also want to make sure that we also talk about what successes people have had in this area as well. So.
I can kind of maybe work that in
Okay.
and still turn it into a problem. So we have had a lot of practice. I'm going to work at a fintech company. And so the cost of failure is quite high, right? Also, people go to jail if you really screw up. So there's a lot of fear about doing things like using something other than version control to isolate branches, or making effectively we have a monolithic deployment like for our microservices because you put it all together. We do an A/B deployment, so there's my success. Where we can decide, to roll it back. I guess I'm interested in if anyone has anecdotes of other companies other than I've heard lots of stories like companies like Booking.com. I used to be at other travel companies.
They're not running an insurance company.
Right. So I'm interested in that, and right. And if anyone has tips on battling that fear.
I have an anecdote, but not on a success side. Like if you, so some root services might choose just because, oh, okay, we are very low in the stack, we are everything else depends on us, so we're gonna go like old bearded way and build once, test for 6 months, and deploy maybe once. But the opposite side of the story is that PMs are working, they promise a lot of features, and then if after the 6 months there is an actual problem that prevents a deployment to happen, then all of the features are blocked because of your monolith, right? So monolith, let's say, had 20 features coming in. Now because of somebody once screwed up, and now the whole thing is moved to another, I don't know, quarter or maybe year. So it's probably more on the not a success side, but on the failure side.
So if you look at the DORA stuff, right? So right? Okay. So one of the paradoxes, right, is that people think that if you move faster, it's going to be more dangerous, right? But it actually turns out that those who have figured out how to move faster end up being more safe. They actually have fewer issues of lesser scope that last shorter periods of time, right? And some of those are fintechs, right? So I can't necessarily, for instance, name all my customers who are in that space. Some have public case studies like WePay, right? That's a financial, they're moving money around, right? They're part of JP Morgan Chase, right? So they care, right? And there's others that are in insurance, et cetera. And the thing is that these things let them be safer. It's not about, you don't want chaos. You don't want somebody who doesn't know what somebody else is doing. That's never going to be okay. That's a human problem, right? But the fact that you can actually control it with a fine-tooth comb, observe it very quickly, and make changes without a huge fire drill actually leaves you in a safer place, right? But it's a leap of faith. I get it. Like if you're from a hardened world where you beat the daylights out of something for 6 weeks with all these tests, but you've lived that tale, right? Then you go out to production and there's a thing you didn't test for that goes wrong in the first 5 minutes, right? And it's not fun, right? So progressive delivery or not, the DORA stuff basically tells you that adopting these smaller payload things, adopting these faster cycle time things, these lead to greater safety, whether you're in fintech or not. And I've personally seen the banks, like 2 years ago, the banks all came to events I was going to and said, we know we're way behind, but we want to catch up. Because they were sort of being very, no, we're not going to the cloud, we're not going to embrace these things. And now they're all generally embracing them. I'm not sure that's...
I think part of that, I think the key thing about this progressive delivery that's helpful and probably maybe helpful for you, hopefully, is that you're putting the onus on the delivery team or the developers to say, well, how do we know when it's successful, right? It's not just, hey, I think traditionally we've said, hey, we're going to do blue-green or canary, and we're just going to push it out there, and then assuming nothing breaks, but we don't quite know what that means, then we're going to keep going.
Strangers in QA and strangers in ops.
Right.
Yeah.
But like, hey, dev team, tell us how we're going to know that it's working or it's broken, and then we're going to sort of gate it, further progress based on that. I don't know. And then I want to make sure that we're also talking about sort of what you want to see in the next 2 to 5 years as far as progressive delivery and that sort of thing. Excellent. Come on up.
I have a thing I'd like to see. With progressive delivery, like it's great for engineers and it's great for product. But what I would like to see are the other stakeholders and how they're impacted. We have a big deal with client ops. They're the ones that are doing the support. So when a new feature just appears, how do they get prepped and how do they get trained up on how to support that feature? Also release notes. We have a huge partner network that's responsible for generating our revenue and selling our products. How do we train them up before we surprise them with this new stuff in production?
So how do the other stakeholders know what features have been released and when?
Or about to be released.
Yeah.
Right? Like, which is, you would prefer that they knew before. And there are some companies that literally use the cohorts they define, or might be like a call center. This call center's been trained, so I'm going to give them the new thing, but I'm not going to move the cheese for those people because they haven't had training yet, right? So it gets back to the keynote talk, which is these things, some of it's tools and technology, but most of it's actually just plain old human, how do we as humans assemble and communicate, right? And so you could implement something like that your stages of rollout include a partner exposure that lasts no less than 1 week. That really would bottleneck how fast you get things out. But if it's better than what you're doing already, right? It's like the dog fooding at Facebook. They have an hour to figure out whether somebody broke their thing. right? You might give your partners more than an hour,
Sure.
right?
Thank you.
Okay, what else would folks like to see?
I think one of the big complexity, big problems to solve in order on this kind of approach to sort of, I think the concept is very similar to A/B testing. It's just it's kind of going like up in topology, in the paradigm. But the problem, even with a simple kind of task of A/B testing, is who is skilled enough to turn all of the signals that we collect, or maybe don't even collect from our applications, into this nice metric. Because on the talk, it's obviously easy to say, yeah, Booking.com, I don't know, changed something on their webpage, and some scientist, crazy scientist, came up with a beautiful graph, like, oh, everything goes up, cool. In reality, I've been in that place where there was a A/B testing proposed, but they said, okay, now you spent like a week implementing a simple UI feature, and now you're going to spend a couple of months building some math model that will turn your signal into something that is relevant and can be used to make those decisions. That's a really hard problem. I think it doesn't really require technology or library. It requires like some skill, because most of those signals will be protocol dependent, platform dependent, maybe some even feature dependent. I know that Bing was achieving some good results just because very smart guys. So for them, every check-in was accompanied with like, maybe it's more of a legend, but it was accompanied with a report, like performance increased, users stayed longer on the pages, and so on. Most of the products just don't have that.
Actually, so the issue, so I missed in my talk, if I didn't make it obvious, that's only a platform if that's automatic. It's not a practice. It's not I have a bunch of data scientists who flurry around and make sense of the data every time I do something. It's only a platform if that kind of repeatable, predictable calculation isn't done by a data scientist. It has to be done by the platform. And the platform has to get smarter over time, right? So the Microsoft platform, all these guys have basically automated that stuff to the point where it's not a smart person making sense of it. The smart people are doing novel things. The system is doing the repeatable thing, right? That's a super important distinction. Like a guardrail. Guardrail, again, isn't something you should be worried about. You should look into it. You should be keeping, no, a guardrail has to calculate itself, or it's not a guardrail. You don't decide, well, am I driving off the side of the road? Well, let me check. I forgot to check. Whoa, here I go. No, you bang into the guardrail, right? And it's always there, right? So it has to be automatically calculated. And you know, like my company was created because we wanted to productize what those people did so that you could just subscribe instead of having to have man years of evolving it, right? So that's why we are out there. But that doesn't mean you couldn't, if you want to build your own, you can build your own. But you have to build that into it and be very disciplined about testing the system itself to make sure it's not telling you lies or it's not doing its feature. It's not performing its function.
Okay, great. One more minute. So.
And I think to the thing of so what to see in 2 to 5 years is that, you know, we'd like to see that I think the tools and all the kind of different pieces that we use have this stuff kind of embedded and can be kind of pulled together. So like we need the data gathering and monitoring and all of that to kind of understand this stuff so that's easy to plug in rather than having to be really bespoke systems that, you know, require a company to have like a lot of expertise and build, you know, custom things to make it work.
Yeah, so like this is not something you want to invent necessarily, right?
Like electricity.
Okay, great. Well, thank you, everyone.